All right, giddy up here. First day back after break. Everyone's super pumped to be at school today. So we are going to long divide polynomials today, and then tomorrow we'll do synthetic division. So we're going to just review the process of long division with numbers. So let's say we have, just make something up here, 4,098 divided by 11. We'll see how this works. So how many 11s go into 4,098? How do you do this? Remember this from way back in the day? So 11 goes into 4, none, right? Not big enough. How many 11s go into 40? You said 3. Good. Now what do? Take 3 times 11 and subtract it, right? So that would be 40 minus 33 is what you said. That's going to leave me with 7. That's smaller than 11, which is good. If it wasn't, then I should have done one more. All right, now I bring down the next number, which is 9, and I start that process over again. How many 11s go into, what's that? How many 11s go into 79? 7. Okay, 7 times 11 is 77. Subtract that. I'm left with a 2. Bring down the 8. How many 11s go into 28? 2. 2 times 11 is 22. Subtract that. And this number down here is my remainder. So when we were in elementary school or younger, we might have just put like R6. Remember doing that? Okay, yeah, those are the good days. So it's kind of funny, I'm a math teacher now, and that I remember doing that R6, and I did not make the connection at the time that is actually a fraction. That 6 is the fraction 6/11. That's what the remainder is, because it doesn't go in evenly. So if you divide 4,098 by 11, you get 372 and 6/11. That's what the remainder is. I don't know, when I was little, it was just R6. But it's actually a part of the fraction that you're dividing. Yep, good job. So we are going to do that now with polynomials. Okay? So here we go. Pumped, yep. So what I want to do is I'm going to divide x squared plus 5x minus 28, that trinomial, divided by the binomial x minus 3. I'm actually going to go back to that scratch paper page there for a sec. We've already kind of done this with factoring. So let's just say I asked you to factor, I don't know, x squared plus 4x, I don't know, minus, what would be a factorable one here? Two factors or a number that has two factors of difference of 4, 7 and 3, let's go 21. Okay, does that factor? Yep, so we can factor this. That's going to be x and x. Factors of 21 that have a difference of 4, 7 and 3. Like that, right? And so now it's factored. What did I just do? I essentially just also did this. X squared plus 4x minus 21 divided by x plus 7 is equal to what? X minus 3. So like you've already kind of done this a little bit when you factored. It's just that you haven't really framed it up to be that way. But that's what you do when you're factoring, is you're finding two things that multiply to equal something, which is essentially it's kind of like dividing. So now we're going to do that, but we're going to do something that doesn't work out nice and neat and happy. It has remainders. So we want to check and divide this trinomial here, x squared plus 5x minus 28, and divide that by x minus 3. So we set it up the same way. I guess now is a good time to mention something too. When you write a number, like this number that I wrote right here, 4,098. This 0, that represents a number of hundreds, right? That's the hundreds place. If I did not have that 0 written right there, and I just had 498, would the answer be right? It wouldn't be the right number, would it? Okay, so it makes total sense for us to put zeros in placeholders like that, but it's less intuitive for us to put zeros in placeholders in polynomials, right? So if you look at each degree in the polynomial, and if there's any unaccounted for terms, you have to put in like a 0 term. So in this case, we have our constant, our linear, and our quadratic, and we're not missing anything there. Okay, but if we had like this, if it was like x cubed plus 2x minus 6, okay, when we write polynomials, we usually don't write 0 terms in. But when you're long dividing, you would have to write in like x cubed plus 0x squared plus 2x minus 6. But we usually just don't write that 0x squared term in our polynomials. But if you're long dividing and synthetic dividing, you have to write that in. Okay, it doesn't come up here and here, but on the next page it does. Okay, let's do it. In this case, when we're long dividing polynomials, it's not like we're thinking, oh, how many x minus 3's go into x squared plus 5x? It's not like, it's just not, doesn't have that numerical representation. There's variables in there. It's not, can't think of it that way. So you have to think about it as terms of like the leading coefficients. If I was going to look at the problem that I just did with the FOIL, where was it? Down here. When I found factors of this, how did I get these factors right here? X and X. Because they were two numbers that multiplied to get that one, right? So that's kind of the way we're thinking about this here, is what would I have to multiply x by to make it equal x squared? X. So that's how you determine what goes here. Okay, now you have to take that x and multiply it by this binomial x minus 3 and subtract it. So I like to write out my blank little subtracting binomial there. What do you get when you take x times x minus 3? X squared minus 3x. Now if I subtract x squared minus 3x, you have to be a little careful because you have to distribute that negative and apply it to each term. So I like to just say, let's add the opposite and change all the signs. So instead of minusing, I'm going to add, and then I distribute that negative and change all the signs to the opposites. So it becomes a negative x squared and a positive 3x. These first terms right here, these terms, should always be the same and they should always cancel out. If they didn't, you made a mistake somewhere. So when I subtract this, I have 5x plus 3x, which is 8x. Bring down the next term, minus 28, and start the process over. So what times x, right here, what times x equals 8x? 8. Okay, take that 8, multiply it by the binomial x minus 3, and subtract it. 8 times x minus 3 would be 8x minus 24. Change it to adding and change all the signs. That becomes a negative, that becomes a positive. The 8x stuff cancels out. Negative 28 plus 24 is negative 4. There's nothing more to bring down, so that will be my remainder. Negative 4 over x minus 3. So it did not go in evenly because there was a remainder, right? If the remainder is 0, then it was like a perfect factor, or it divides evenly. How neat is that? I mean, dividing polynomials, that's pretty wild. Jada, pretty wild. Yeah, that's whack. All right, let's try it again. What times 3x equals 15x squared? 5x. Good job. 5x. Take 5x, multiply it by that binomial, and subtract it. 5x times 3x plus 1 going to be 15x plus 5x. What the heck? I mean squared. Change the minus to a plus and change all the signs, right? So don't forget to change all the signs. And that leaves us with an 8x minus a 5x for a total of 3x. Bring down the negative 12. Start the process over. What times 3x is 3x? That's a 1. Don't let it be too easy, it screws you up. 1 times 3x plus 1 is 3x plus 1. Subtract it. Change the signs. Plus, change that to negative, change that to a negative. Looks like I have a remainder of negative 13. Neat. Not many people can say that they can divide polynomials, long divide polynomials. What percentage of the total population of the planet you think can do this?
5%.
I mean, you guys are special. You're working towards special things here. It's because why do you need to do that? Right? All right, last one. This is where it comes up where you have missing terms. So, hey, and just for practice, what is this? If you were to name this polynomial right here, what would be the name of that? You would call that a fourth degree or a quartic trinomial. Good, trinomial, because it just has 1, 2, 3 terms. Quartic trinomial or a fourth degree trinomial. But that actually is if it's fourth degree and it's only a trinomial, that means it's missing some terms. Okay, so we have to be sure to, when we write this out, put our 0 terms in. So x plus 3, x to the fourth plus 0x cubed plus 0x squared minus 5x plus 10. So this one's a little longer. It's important that you be neat, organized, go slow. Watch out for little mistakes. What times x gives you x to the fourth? X cubed. Multiply by that binomial and subtract it. You know, and when you're doing that, all the terms that you should line up vertically should be like terms. I added it in because it's not present up here, right? So you have to add those terms in there, right? Adding missing terms. Okay, good question. So now everything lines up. Instead of subtracting, I'm going to add the opposites, so I just change all those signs, and what I have left down here is a negative 3x cubed. Bring down the next term, which is a 0 term. If I didn't have that 0 term in there, things would not line up. Like terms would not be lining up. Start the process over. X times what is negative 3x cubed? Negative 3x squared, right? Multiply negative 3x squared times the binomial here, x plus 3, and subtract it. So this, you got to watch out for the negative. It's going to be negative 3x cubed. And look, these should be exactly the same, right above each other. So when you subtract them, they cancel out. So negative 3x cubed, and multiply by the 3, I get negative 9x squared. Instead of minusing or subtracting, I'm going to change it to adding, change the opposites to both those. Those both become pluses, and I'm left now with 9x squared. Bring down my next term, which is a negative 5x. Start that process over again. What times 9x, or x is 9x squared? Plus 9x. And look at these terms in the answer are going down in degree one at a time, right? X cubed, x squared, 9x. Okay, 9x times x plus 3. Subtract that binomial. I get 9x squared plus 27x. Distribute the negative or change all the signs. I'm left now with negative 32x. Bring down the last constant term, which is a plus 10. Start the process over again. X times what is negative 32x? Negative 32, good. Multiply that, distribute, negative 32x minus 96. Change the signs. What's my remainder? 106. Remainder, 106 over x plus 3. That is pretty neat. I mean, Jada, that is off the hook. Yeah. So that's it. That's long division. About 15 minutes. That's what they say the attention spans are now. You can't go over 15, right? Isn't that the deal? I'm getting some weird looks. Not true. Okay. So you'll have some time to work. Signing off here now. Bye for now.